I've got two questions on that. So
Yeah.
the first is about dementia and Alzheimer's. Do we know what's causing it?
No.
We still don't know.
Nope. And there's not good drugs, unfortunately, right now.
There's a lot of links to lifestyle choices though, right?
Yes, absolutely. And so, of course, based on what I just said, my number one most powerful tool that you can do to protect your brain from aging and neurodegenerative disease states is start walking. Why do I start with that? Because everybody can walk. You don't need to buy any new fitness outfits. Just go out and walk more. And then they say, oh, well, do I have to become a marathon runner? That could help too. But everybody can walk. And from that study that I mentioned in the 65-year-old, 30% reduction in the probability of getting Alzheimer's with just walking.
You said that if I go and start walking and I do exercise, my prefrontal cortex will grow, which is the decision-making center, right?
Yes.
So does that mean then that if I am somebody who is very sedentary, I don't do much physical activity, that my decision-making will be worse compared to what it could be with the same person if they were active?
Yes. I mean, that there is that potential. Brain plasticity and the neuroscience of brain plasticity tells us that absolutely with physical activity, you have great potential to improve the function of your prefrontal cortex. And I must specify a little bit, the main function that has been shown to be particularly sensitive to regular physical activity is shifting and focusing your attention. So being able to listen to me while you might be paying attention to the AV guy that might be telling you something right now. So to be able to do that effectively, that is one of the things that we know is helped with regular physical activity.
Focus and attention,
Yes.
that kind of thing. Okay. You talked about memory as well. Does that exist in the prefrontal cortex as well?
There's a form of memory, working memory, which is kind of scratch pad memory. It's a memory that when we used to have to remember telephone numbers, that ability to remember a 7-digit, at least in the United States, telephone number. It's different from long-term memory formation, which is memory for facts and events that is dependent on the hippocampus.
I feel like my memory's not great.
Most people feel that.
Why is my memory not as good as other people? Because I noticed this when I was with my friend in Thailand many years ago. I think I was 21 years old. And we could like leave the house and go on our little mopeds for about an hour.
Yeah.
And he could navigate us back home without needing sat-nav or Google Maps. And if I go 3 minutes down the street, I'm lost. And I always wondered why that was. And then even with names and stuff, he's my best friend. He still is one of my best friends for 7-8 years. We ran a business together and he would remember every name of every person and I couldn't. I wouldn't. And so I'd always turn to him and say, what was that person's name again? What's that, And I always wondered why my memory, he seemed to have this incredible memory and mine seems to be pretty rudimentary.
I would argue that, everybody has parts of their memory that aren't as good as they want, but also other forms of memory that they're very good at. So I would guess, I've only just met you today, that your memory for stories and storytelling and story progress is excellent because it has to be for the job that you do. I bet you it's much better than your friend that can navigate back. Not everybody has a perfect memory in all the different dimensions. And it's like our personality. Some people have a wonderful sense of humor and others don't. It is about how our brains are wired, which is defined both by nature and nurture, our genes. And, if I went to stand-up comedy class, I would probably get funnier. But there's probably a limit to my funniness compared to other people.
So there's different types of memory.
Yes.
In your book, you talk about there being, I think it's 3 different types of memory in total that are formed in the hippocampus.
There's lots of different names for forms of memory in the hippocampus, but I like to describe it as the hippocampus is critical for our memory for facts and events, also called declarative memory or cognitive memory. Another form of memory that's dependent on a completely different structure is motor memory, the memory that you use to learn how to play tennis or pickleball or whatever you're playing. And it's not declarative. I can't declare how I do a backhand in tennis, but it is in your motor functions. And this is dependent on the striatum, a motor-related structure. And then there's the prefrontal cortex, dependent on that working memory or scratch pad memory, keeping things in mind. So you and I are both trying to remember what we've just said so we can link it to things that we might say in the future.
Well, one of the things that I found really interesting, both as a marketeer, but also as a podcaster and as someone that's making a lot of content and trying to get people's attention, was as I was reading through your work, it became quite clear to me that there's a bit of an overlap between memory and attention in many respects. Because
absolutely.
You were talking about these 4 things that make facts or events memorable.
Yes.
And many of those things are things that I think about as a marketeer when I'm trying to get someone to, engage with something, click on something, buy something.
Yeah.
What are those 4 things?
Okay.
Can we go through them?
Absolutely. So I like to say there are 4 things that make memory stick. And this is after 25 or 30 years studying the hippocampus and how memories work. Number 1 is obvious, repetition.
Okay.
You remember things with repetition. Number 2, not as obvious, association. The hippocampus is an associative structure. It associates one thing with the other. For example, your name and your face. So I just met you, and I will remember your name and your face now. But it also helps you remember things like who's married to each other, associating the husband with the wife. Have you heard of the memory palace?
Yes.
Yes. So this is a technique that has been used for many, many ages to help remember things. And it is a strategy where you picture a spatial location that's very familiar to you, like your childhood home. And when you need to remember a list of items, you take an imaginative walk through that very familiar environment and place those items in particular locations in the environment. That is associating something really familiar, your childhood home, you know every corner of it, with the new thing you need to remember. And that works and has worked for memory champions for many years because the hippocampus associates things together. That's number 2, association. Number 3 is novelty. We remember novel things. I've never been to this particular studio ever before in my 26 years in New York and Brooklyn. So this is a novel thing, and I will remember coming here to do this podcast with you. Our brains, and this is where it interacts with the attention system. Our attention system focuses on things that are novel. Why? Because it could be dangerous. If I've seen things over and over and over again, I don't notice them. They go into the background. It's not going to hurt me any, it's not going to cause me any danger.
Cliche. That's why cliche doesn't work in marketing.
Exactly. Yeah. And so, but something novel, that really perks people up. I use that in my teaching all the time. Surprise students with an element of what you want them to learn, and they will remember it better. But the 4th one, which is so powerful, and we know it intuitively, we understand this intuitively, is emotional resonance makes things more memorable. We remember the happiest and the saddest things in our lives because that emotional resonance solidifies those memories. Where does that come from? It comes from a structure called the amygdala that sits right in front of the hippocampus, right in the front of the temporal lobe, right here. And the hippocampus is right behind it. Amygdala means almond. It's an almond-shaped structure, and it sits right in front of the kind of tube-shaped structure that is the hippocampus behind it. And the amygdala is kind of infusing the hippocampus and kind of giving it a little jolt when it's emotionally resonant, either really happy or really sad.
You brought with you what you've told me is a real human brain.
Yes, I did.
Now, I'm not sure if you're just winding me up, but we're talking here about novelty and surprise and
that's right.
Things you'll never forget and emotional resonance.
Correct.
And as you're saying that, I was conscious that over in the corner of the room, it appears that there's a human brain in a box. So Jack is just bringing the human brain in.
Yes.
I've never seen a human brain before.
You've never seen, that's why I brought you gloves so that you can hold it if you like. If you like.
Do you have permission to, if there is a human brain in this box and you're not winding me up, did you have to get permission from the owner of that brain?
So this was purchased lawfully by my department, the Center for Neuroscience at New York University. So it is lawfully ours to use as a teaching tool. And it does bring enormous novelty to any situation that I go into and makes people really think about their brain in a new way, which is why I bring it.
What is in that box?
In this box is a real preserved human brain named Betty.
Was the person who used to own that brain called Betty?
No, we don't know the name of the person.
Okay.
I named this brain Betty. So
can you tell if it's a man or a woman?
No, I can't.
Oh, men and women brains not different at all?
They are, but in very, very subtle ways that we wouldn't be able to tell just looking at the outside of the brain like this.
Okay, I'm ready.
Are you ready?
I think so.
Okay, so I'm going to open the hat box.
No way is that
and I'm going to pull out.
Are you joking? Is that really a brain?
It is a real preserved human brain. There it is. Frontal lobe, occipital lobe for vision, occipital lobe back there. And in this brain, I don't know if you can see it from over there, if I pull apart the two hemispheres, you can see how deep the folds of the brain, the surface is folded in that deep into the brain, which expands the surface area of the outside of the cortex. The rat cortex is flat. There's no folds. Humans and elephants and dolphins have lots of folds. They have much higher capacity for computation because of the folds that you see in this brain.
It's smaller than I was expecting.
Really? Half the people say it's smaller, half the people say, wow, that's enormous.
Interesting. Is that the color of a brain?
The color of the brain is darker than the real brain if we opened up my head right now because of the formaldehyde, the preservative chemical that this has been sitting in for at least 26 years. This brain has been in my department for ever since I got here 26 years ago.
I feel like I probably should hold it.
I think you should hold it.
Oh my God. It's wet.
Yes. So, I mean, that defined this person's whole life. How they saw, felt, smelled, heard, and thought about the world. Just right there in your one hand, in your right hand.
It's crazy to think that this little thing is, it's different underneath.
Yes.
It's crazy to think that this little thing,
That's the start of the spinal cord right there that you're pointing at.
And this stuff underneath at the back.
That is the cerebellum, brain structure critical for fine motor movement. So we wouldn't be able to walk smoothly if you have damage in your cerebellum.
Isn't it interesting that everything, as you say, everything this person worried about, every thought, every memory, every relationship, all of their education, the school they went to, the university, everything they saw and remembered, and all of their trauma and their anxiety and maybe their depression, everything they went through, even their last days before they died, is captured in this little ball of tofu. That sits in my hand, an entire human being's existence.
It's true.
What they watched on TV, their favorite movie, their favorite number, color, everything is in this tiny little ball of tofu.
It's crazy. True.
Oh, gosh.
It is amazing. And actually, in real life, firm tofu is the consistency of the brain. I often bring in a block of firm tofu when I demo this for students, in addition to Betty.
Do you remember the first time you saw a human brain?
I do.
Did it change how you think about your own brain?
It changed my life because I was like, I want to study that. That is the coolest thing that I've ever seen in my whole life. And I want to study that, and I want to be just like her. And so it really okay, now I decided this is what I want to do. And it was life-changing.
I say that because at the start of this conversation, we said that most of us don't appreciate our brain. A lot of people don't even realize it's there. But the minute I had a brain scan one day, and that brain scan really changed my life, because seeing my own brain for the first time, it was the push that I needed to start caring more about how my decisions and behaviors are impacting it. So let's talk about how I can make that ball of tofu in my head super healthy, super big, fat, and fluffy.
Right.
You talked about exercise earlier on, but we didn't really dig into exactly what you mean by exercise, because exercise, I think, is multifaceted in its definition. What kind of exercise should I be doing to make my ball of tofu in my head great? Optimal.
Well, all the research shows that the best kind of exercise that you can do is anything that gives you aerobic activity, that is getting your heart rate up. So that goes for, power walking will get your heart rate up. Soccer, so many different things. Name your activity. So many people want to say, oh, well, my favorite activity, will that work? And I always just say, is your heart rate up when you're doing it? If the answer is yes, then that works great. We know that level of aerobic activity is critical, because that's going to release that growth factor maximally to get into your hippocampus that will grow those new brain cells.
How much?
So I have an answer to that. So we did 2 different experiments in my lab. One in low-fit people that are really not exercising very much at all, less than 30 minutes in the last three weeks you've moved your body. And we asked, could we see any behavioral improvement in your memory function from your hippocampus or your ability to shift and focus attention if we ask you to move your body in an aerobic way for 2 to 3 times a week? And we collaborated with a spin class, so clearly very aerobic. And what we found was, in those people that did successfully do 2 to 3 times a week a 45-minute aerobic activity, their mood got significantly better, their memory function got better, and their ability to shift and focus attention got significantly better. So that gives a little bit of a guideline for low-fit people. 2 to 3 times a week can start to give you some of those cognitive changes. But you don't look low-fit. So let me answer the question you're about to ask me with, what about me? I exercise pretty regularly, and how much do I need? So to answer that question, we went to another spin studio and we said, look, we're going to give you free classes. You could exercise as much as you want in this at this studio, and go up to 7 times a week. And the control was just stay the same. They were working out twice a week at the studio.
Control was the other group that you were testing them against?
Yes, okay. Exactly. And so what we found was basically every drop of sweat counted. The more you exercise, the more change in your brain we noted, both your hippocampal function, prefrontal function, and mood. If you were already getting benefit, you're already going twice a week, but the more you did, the more brain changes you got. So that doesn't give the formula that I would like, but we were heading in that direction, which is part of one of the questions that I want to answer. But I love to leave people with the idea that every drop of sweat counts for building your brain into the big, fat, fluffy brain that you really want.
And then in the real world, again, making it super real for people.
Yeah.
How does that change how I show up?
Yeah. If you allow it to, should have a beautiful effect on your mindset. That your mindset around how often should I wake up 30 minutes early and do that walk before I start my day, or accept the invitation to go walk the dog with a neighbor. It's not an obligation. It is something that you're doing for yourself. It is going to have direct benefits on that ball of tofu, as you call it, in your head. It's going to make it work better. And I mean, I think the most immediate thing that I benefit from every single day is the mood boost that you get from that serotonin, dopamine, noradrenaline that gets released every time you move your body.
I always think that because obviously I do a lot of podcasting and I'm super reliant on my brain being attached to my mouth. And sometimes I notice that it's not. You know what I mean? Like sometimes I'm not articulate, I can't get my thoughts together, whatever.
Yes.
And I always try and figure out the correlation between what I did that day when I have a good day versus a bad day.
Yeah.
And from your, and also I speak on stage sometimes. So I've often asked myself, because I saw Tony Robbins, the speaker, one day on a trampoline before he goes up on stage.
Yeah.
I asked myself, okay, should I be doing a workout in my green room before I go up on stage for a big talk or presentation? You think I should?
Oh yeah, absolutely.
What's the basis of that in science and neuroscience?
The basis is that immediate so there's 3 key effects that we know happen every time you move your body. First one is mood. You're going to get your dopamine, your serotonin up. Second is focus and attention. So a single workout isn't going to make more synapses in your prefrontal cortex, but the prefrontal cortex uses dopamine. And so it's clear that even a single workout can make your prefrontal cortex work better in terms of focus and attention. Also very important anytime you're speaking. And the third is reaction time. Your reaction time is, motor. You're working your motor cortex when you move your body, and your response and reaction time is significantly shorter after even a single workout compared to if you just don't work out and sit alone. So great things to do, a great thing to do before you stand up and speak.
If you love the Diary of a CEO brand and you watch this channel, please do me a huge favor. Become part of the 15% of the viewers on this channel that have hit the subscribe button. It helps us tremendously, and the bigger the channel gets, the bigger the guests.